Welcome students, our 8th chapter is predicting what comes next, exploring sequences and progressions. Before we are getting into 8.1, we will see some introduction part because first time you're going to learn what is sequence and progression. First we will see what is sequence. Introduction part. So look at the definition of the sequence. A sequence as an ordered list. Sequence as an ordered list of numbers where each number is a term of a sequence. Look at here, few sequences are there, 1 2 3 4 5 6 etc. 1 3 3 5 7 9 11 etc. 2 4 6 8 10 12 etc. till 94 6 11 16 21 etc. Here in this first sequence, 1 is first term, we can say T1, term 1. 2 is term 2, 3, term 3, T3, T suffix 4. So that is the indication of the term. T5, 6 we can write T6. In same way, second sequence, 1 is T1 and 3, number 3 is T2, number 5 T3, number 7 T4, like this. Here T 2 is T1, 4 is T2, 6 T3, this is T4, T5, T6, and we don't know few numbers are there and one number is given. This sequence ends with 94, starting number 2 and ends with 94. Previously 2 sequence goes on. We don't know the last number. Here the last number is given, so we don't know that is which term. We don't know that, so we can indicate that as Tn. We don't know that nth term. It may be 10th term, it may be 15th term, it may be 24th term. We don't know what is that, so we are indicating this as T10. Otherwise we can indicate this number as our last term, either Tn or L, last term. Next also like this. So each term, each number is a term in the sequence. Then first sequence 1 2 3 4, we know this is the natural number set. That is, if we are adding 1, we are getting next number, adding 1 next, adding 1 next number. So succeeding numbers, summing 1 with the preceding number, we are getting the succeeding number. Here odd number also, 1 plus 2, 2 we will be getting 3, 3 plus 2 we will be getting 5, 5 plus 2 we will be getting 7, 7 plus 2 9, like this. Here even numbers we can write it in two ways, that is 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. Otherwise another way, 2 into 1 2, then 2 into 2 4, 2 into 3 6, 2 into 4 8, then 2 into 5 10, like this also we can write the numbers. Here 6, 11, 16. So 6 plus 5 we are getting 11. 11 plus 5 16. 16 plus 5 21, and goes on. Like this we can get otherwise. 6 is nothing but 5 plus 1. 11 is 10 plus 1. 16 15 plus 1. So the same sequence can be written in this format also, that is 5 into 1 plus 1, that is 6. Then 5 into 2, 10 plus 1 is 11. 5 into 3 plus 1 is 15 plus 1, 16. 5 into 4 plus 1, 20 plus 1, 21. Like this also we can develop the sequence. Next sequence 1 3 6, first term T1 is 1. Then how we are getting 3? When we are adding 2, we will be getting 3. And if we are adding 3 plus 2, we will be getting 5, but the sequence saying the third term is 6. So adding 2 is not correct here, because 6 plus 2 8 should come, but 10 is there. So plus 2 is not the common one here. So how to get the sequence? That is, first term is 1. Then second term, first two, summing two numbers, 1 plus 2 3. We are getting 1 plus 2 3. Then 1 plus 2 plus 3, we are getting 6. Then 1 plus 2 plus 3 plus 4, we are getting 3, 6, 10. Then 1 plus 2 plus 3 plus 4 plus 5, we are getting 10, 15. So like this, the numbers developed here. That is T1 first number, T2 summing first two numbers, T3 summing up first three numbers, T4 summing up first four numbers, T5 summing up first five numbers. Like this we got the numbers. Next 1, 4, 9, 16, you know very well these are the square numbers. The previous one, that is 1, 3, 6, 10. The numbers are called the triangular numbers because 3 can make a triangle, 6 dots can make a triangle, 10 dots can make a triangle. So these are the triangular numbers. 1, 4, 9, 16 and are square numbers. That is this one formed 1 squared, then 2 squared, then 3 squared, 4 squared, 5 squared, 6 squared, etc. This is 25 squared. So first 25 square numbers are placed here. The another way we can write, that is first term 1. Second term 1 plus 3, we are getting 4. Third term 1 plus 3 plus 5. 1 plus 3, 4. 4 plus 5, 9. And then fourth term 1 plus 3 plus 5 plus 7. So 1 plus 3 plus 5 plus 7 plus 9. That is, this sum is 1, this sum is 4, this sum is 9, this sum is 16. Here we are getting 25. Like this we can write the numbers. Sum of first first odd number, then second sum of first two odd numbers 4, sum of first three odd numbers 9, sum of first four odd numbers 16, sum of first 5 odd numbers 25. Like this, this is sum of first 25 odd numbers. Like this also we can write. Then here 60, 54, 48, 42, 36, 30. So the numbers are reduced. Previously we can see the numbers increased there. So these are the first one, second one, third one and all increasing sequence and infinite sequence. First sequence, this is increasing, this is increasing, infinite. This is also increasing sequence, finite sequence. This is finite. This is increasing and infinite sequence. This is increasing infinite sequence. But look at that. This one is increasing and finite. Increasing finite sequence. Now 60, 54, 48, this one is decreasing sequence. The numbers are decreased here. This is decreasing infinite sequence. Decreasing infinite sequence. How the numbers are decreased? If we are subtracting 6 from 60, we are getting 54. That is 60 minus 6, we are getting 54. Then minus 6, we are getting 48. Minus 6, we are getting 42. Minus 6, we are getting 36. And minus 6, 30. Otherwise, this is 6 multiples in decreasing order. The next decreasing, once again we are having decreasing and finite. The last number is given. This is Tn. We don't know which number, which term is that one, Tn, and we can name it as L. So it is decreasing and finite sequence. That is 7 minus 4, we are getting 3. 3 minus 4 minus 1. Minus 1 minus 4 minus 5. And minus 5 minus 4 minus 9. Like this we can get. So sequence may finite or infinite. Sequence may increasing or decreasing, whatever it may be, if it is in some order or accepting some rule. The terms follow a certain pattern, rule or order, then it is called a sequence. Then the way of describing a sequence by relating term to previous terms is known as recursive rule or recursive formula. So here we got no, from the preceding number subtracting minus 4, we are getting this one. Like this here, say this one, so look at this one. Here 5n plus 1. So like this we got a pattern, no, that is called recursive rule. So we got 5, 1 plus 1. We are getting next number 6. Then 5 into 2 plus 1. The next number 10 plus 1, 11. So like this we can get any number 5 times n plus 1. We can get any numbers. Like this, if we are getting a general rule, that is called the recursive rule or a formula. So using this, we are going to find the answer for first exercise. Look at the first question. Find the first 5 terms of the sequence in which nth term is given by. So here 3 subdivisions are there. All the 3 subdivision, nth term is given. N is greater than or equal to 1. N is not equal to 0. N is greater than or equal to 1. We need to find first 5 terms. So for finding first 5 terms, say T1. T1 means in the place of n, we need to replace 1. So 3 into 1 minus 4. We are getting 3 minus 4. So 3 minus 4 is minus 1. So this is T1. T2. So in n's place, we need to replace 2 minus 4. So 6 minus 4, 2. T2, 2 plus 2. Then T3. This is second term. T3. 3 into 3 minus 4. 9 minus 4. So third term is 5. T3, 5. Then T4. 3 into 4 minus 4. 12 minus 4. T4 is 8. Fourth term 8. Then T5. T5. 3 into 5 minus 4. 15 minus 4 is 11. Plus 11. So T5 here is 11. So the sequence are the 5 numbers can form a sequence. The sequence here is first number minus 1, then next number 2, then 5, 8, 11, and it all goes on. Like this we can develop the sequence. Now look at that next one. Here T1, 2 into minus 5 into 1. So 2 minus 5 is minus 3. Our T1 is minus 3. Then T2. T2. 2 into 5 into 2. So 2 minus 10 is minus 8. T2 is equal to minus 8. Now third term. T3. 2 minus 5 into 3. 2 minus 15 minus 13. T3 is minus 13. T4. 2 into 5 minus 4. 2 minus 20 minus 18. So T4 here is minus 18. T5. 2 minus 5 into 5. 2 minus 25 minus 23. T5 is minus 23. So the sequence here is minus 3, minus 8, minus 13, minus 18, minus 23, and so on. So first one is increasing sequence. This one is decreasing sequence. The second one is decreasing sequence. Next, T1, 1 squared minus 2 into 1 plus 3. So 1 squared is 1 minus 2 plus 3 will give plus 2. T1 here is plus 2. Then T2. 2 squared minus 2 into 2 plus 3. 2 squared is 4. Minus 2 into plus 2 minus 4 plus 3. So the sum is 3. So T2 is plus 3. T3. 3 squared minus 2 into 3 plus 3. 3 squared 9 minus 6 plus 3. So 9 minus 6 plus 3, then plus 3 plus 3, 6. T3 is equal to 6. Now T4. T4 is equal to 4 squared minus 2 into 4 plus 3. 16 minus 8 plus 3. 16 minus 8 is plus 8. 8 plus 3, 11. T4 is 11. Then T5. T5 is equal to 5 squared minus 2 into 5 plus 3. 25 minus 10 plus 3. 25 minus 10 is 15 plus 15 plus 15 3 plus 3 is 18. So fifth term is 18. The sequence here we can write 2, 3, 6, 11, 18 and so on. These are the first 5 terms of the given sequence. Nth term is given, so we can find the numbers. First 5 numbers. Second question. Find the 10th and 15th term of the sequence. Just in n's place we can replace the number and we can find. That is 10th term. 10th term T10. N's place 10. 5 into 10 minus 3. So 5 into 10, 50 minus 3 is 47. So 10th term of the sequence is 47. So without finding first term, second term, directly using the form, recursive form, we are finding the required one. 5 into 15 minus 3. So 5 into 15, 25, remaining to 5, 75. Minus 3 is equal to 72. So T15 is equal to 72. Next question. Determine whether 97 and 172 are terms of the sequence. So we need to check whether these are the terms of the sequence. So first we can take 97. So how to find 97? We can consider that is our last term. Say Tn is equal to 97. If we are getting our n as the whole number, then we can say 97 is the term of the sequence. Otherwise, we can conclude here Tn is given 5n minus 3 is equal to 97. Now, we need to check our n is a whole number or not. So, 5n transposing minus 3 to that side plus 3. So, 5n is equal to 100. N is equal to 100 by 5. So, exactly 5 will divide 100 20 times, which means 20th term of the sequence is 97. So, we can conclude yes, 97 is a term in the sequence. Yes, 97 is a term in the sequence, that is T20. 20th term of the sequence is 97. Now, we can check the next one. That is 172. So, here we need to consider let Tn is equal to 172. So, Tn is 5n minus 3 is equal to 172. So, 5n transposing 3 to next side 172 plus 3. So, 5n is equal to 175. N is equal to 175 divided by 5. So, 5 will divide 175 exactly 3 times 15, remaining 2, 5 times, 35 times. So, n is as a whole number or we can say natural number. We can conclude yes, 172 is a term in the given sequence. Which term? that is the 35th term. T35 is equal to 172. 35th term is 172 and 20th term is 97. Next question, which term of the sequence Tn is equal to 5n minus 3 for n is greater than or equal to 1 is 607. So like previous question, we need to take our Tn is equal to 607, then find the nth, what is the n? So 5n minus 3 is equal to 607. 5n is equal to 607 plus 3. So 5n is equal to 610. N is equal to 610 by 5. N is equal to 1 time remaining 1, 2 times 10 remaining. So N is 122. T122 is equal to 607. 607 is 122th term in this sequence. 122nd term is 607. Fifth question, a sequence is given by the recursive rule T1 is equal to minus 5. So here we are getting T1 first term minus 5, then Tn plus 1. Tn plus 1 is equal to Tn plus 3. This is the common rule for n is greater than or equal to 1. Find the first 5 terms of the sequence. That is first question. Next, is 52 a term of this sequence? We need to check that. If so, that is, if 52 is a sequence, which term is it? We need to find. Now T1 given as minus 5. To find T2, look at the general format. If I going to replace n is equal to 1, so 1 plus 1, I will be getting T2. T2 is equal to T1 plus 3. Right hand side, Tn plus 3, T1 plus 3. So T1 minus 5 plus 3 minus 2. So T2 we got minus 2. This is T2. In the question, T1 given here. Then n is equal to 2. So 2 plus 1, T3. This is the third term. Right hand side, if you are replacing n is 2, T2 plus 3. So T2 is minus 2 plus 3 plus 1. So we are getting T3 is equal to plus 1. This is second term. Now n is equal to 3 in the left side. T3 plus 1 is T4. So fourth term, right hand side, if you are replacing 3, T3 plus 3. T3 is plus 1 plus 3, 4. So T4 is equal to 4. Then T5, fifth term, n is equal to 4. We will be getting T4 plus 1 is equal to T5, which is equal to T4 plus 3. T4 is 4 plus 3, 7. So T5 is equal to 7. Now we got the first 5 numbers as 5, minus 2, 1, 4 and 7. These are the first 5 numbers. How we got this? We are adding plus 3 to the first number. We are getting the second number. Second number plus 3, third number. Third number plus 3, fourth number. Fourth number plus 3, plus 3, fourth number. Fourth number plus 3, fifth number. Fifth number plus 3, sixth number. That is T1. First number is minus 5. Then to get T2, with T1 we are adding 1 time plus 3. Then for T3, with T1 we are adding 2 times. That is 2 times 3. Then only we are getting the given number. That is T1 is equal to minus 5 plus 3. We will be getting minus 2. Now T3, comparing T1, 2 times we need to add 3. So T1 is minus 5 plus 6 is equal to plus 1. So we got the answer. Now for T4, T1 plus 3 times the number 3. So T1 is minus 5, 3 times 3, 9, we are getting 4. Then T5 is equal to T1 plus 4 times 3 is equal to minus 5 plus 12. We are getting 7, which means how to find Tn? Look at here. Look at the previous cases. 5 means 4 times. 4 means 3 times. Compare this. That is, what is the n is given? 1 means nothing is added. T2, we are adding only 1 time 3. For T3, we are adding 2 times 3. For fourth term, we are adding 3 times 3. For fifth term, we are adding 4 times 3. So, for nth term, T1 with T1, we need to add n minus 1 times. Because 4 is 5 minus 1, 3 is 4 minus 1, 2 is 3 minus 1. So, n minus 1 time 3. If we are adding n minus 1 time 3 with T1, we will be getting nth term. So, using this, we can check whether 52 is the term or not. So, we are going to consider let Tn is equal to 52. So, T1 is, that is T1 plus n minus 1 into 3 is 52. We are going to consider T1 is minus 5 plus n minus 1 into 3 is equal to 52. Transposing minus 5 to next side, we will be getting 57. 52 plus 5, we will be getting 57. Now divide that with 3. That is n minus 1 is equal to 57 by 3. How many times? N minus 1, 1 time 3 remaining 2, 9 times, 19 times. So, n is equal to 19 plus 1, n is equal to 20. So, we got a whole number, n is a whole number. So, we can conclude, yes, 52 is a term of the sequence. Then which term? 20th term of the sequence. N is 20. So, T20 is equal to 52. 52 is 20th term of the sequence. Next question. Let T1 is 1. That is T1 is equal to 1. T2, 2. T3, 4. This is given in the question. And Tn is given Tn minus 1 plus Tn minus 2 plus Tn minus 3. This is given. Find T4, T5, T6, T7, T8. Now, in the place we can replace 4. What can we get? T4 is equal to T4 minus 1 plus T4 minus 2 plus T4 minus 3. That is T3 plus T2 plus T1. So, to find T4, we need to add this. What is T3? 4 plus 2 plus 1. So, T4 is equal to 7. We got T4, 7. Now, T5. So, for T5, T5 minus 1 plus T5 minus 2 plus T5 minus 3. So, T4 plus T3 plus T2. T4 is 7. T3 is 4. T2 is 2. So, 13. Now, we got our T5 is 13. Next, T6. T6 is equal to T. Look at the previous two. T4 we are getting T3, T3. Look at this and we can write. That is T4 is T3 plus T2 plus T1. T5 is T4 plus T3 plus T2. So, T6 is T5. That is n minus 1, 5. Then n minus 2, 4. Then n minus 3, 3. So, T5 is 13. Then T4 is 7. Then T3 is 4. So, 24. We got T6 is equal to 24. Now, T7. T7 is equal to T6 plus T5 plus T4. T6 24, T5 13, T4 7, 20 44. So T7 is equal to 44. T8 is equal to T7 plus T6 plus T5. T7 44, T6 24, T5 13. So 8, 11, 5, 6, 7, 81. So T8 is 81. Like this we can find any terms.